In this video, you will learn 8 important concepts and language features that I think you and me should be very familiar with. Nowadays, I think a lot of us are just caught up with learning these new technologies, these frameworks like Django, Fast API, Flask, and so on. So learn the core principles and the syntax, but do not memorize it. Never memorize the code, but just learn the logic. And then you can move on to learn frameworks. Alright, so thank you very much guys, and I hope you enjoyed the video. In this short video, I'm going to talk about a very important concept in Python and in programming in general. References. Let's have a variable, we'll call it price, and this will be equal to 5,000, simple integer. And let's assign price to another variable, we'll call it car. So car will be equal to price variable. Now let's try to alter this price variable and change the value. So we will have 7,000 for instance. So if we will print car is logically equal to price, which is equal to 7,000. So let's see what car has. 5,000. But when we will print price, we have 7,000. Let me explain. When you assign 5,000 to the price variable, you're actually creating the 5,000 value in the computer's memory and storing a reference to it in the price variable. And when you copy the value in price and assign it to the variable car, you're actually copying the reference. So both car and price point to or refer to 5,000 in the computer's memory. When you later change the value in price to 7,000, you're creating a new 7,000 value and storing it in a second price variable. This doesn't affect the value in car actually, as integers are immutable values which don't change, and changing the price variable is actually making it refer to a completely different value in memory. And this doesn't work on lists, for instance, because lists are mutable data type. So if we'll have a value called numbers, and we'll have simple integers 0, 1, 2, 3, 4, and 5. And let's have any variable, for instance Jordan is equal to numbers. So if we want to alter any value inside numbers list, so if we want to change the number 1 to be a string, so let's have Jordan with the first index to be equal to greetings. Now, if we'll print numbers and if we will print Jordan, we will get the same result because both numbers and Jordan are referring to the same reference in the computer's memory. And this was references explained briefly in immutable and mutable data types. In this video, I'm going to talk about lambda expressions. In Python, to define a normal function, you will need the def keyword. Let's create a function that will return a square number. So we'll use the def keyword, followed by the name of the function, which is square for instance. Then the input, or the parameter that we will need to pass when we will call this function. We will close the parentheses and colon. Then return, which is the return statement that returns the result of this multiplication. X multiplied by x. Enter, enter. If we'll invoke this function square and we will pass any number, let's say 3, we will have 9 as a result. Not all functions need a name though. These nameless functions are called anonymous functions or lambda expressions. These functions can have any number of arguments, but only one expression, which is evaluated and returned. Lambda expression and anonymous function mean the same thing. To create a lambda expression, just type the keyword lambda, followed by your parameter or input, which is the x, then colon. Then we will need finally to write the expression that returns the x square, which is x multiplied by x. Enter. This is useless, as the result of this expression will return a memory location on your computer. As a matter of fact, you cannot use lambda expressions just like that, because it doesn't have a name. Be careful. lambda is not the name of the function, but it's a keyword that describes what follows is an anonymous function. In order to use it, you have to give it a name. And let's call this lambda expression a. So a will be equal to lambda x colon and the expression, which is x multiplied by x. Now you can use this like any other function. So you will invoke that a and you will pass inside 3 and it shall give you the same result, which is 9. Let me give you another example with multiple inputs. If I want to create a function that combines the origin and destination of flights for some survey, for instance, and let's call this lambda expression path, will be equal to, and we'll use the lambda expression or anonymous function, lambda, and instead of giving it one input, we will give it two inputs here because we will need an origin and destination. We will call the first input O and the second D, colon. Then I want a string telling me that the origin, then space. So what I did here is I called a lambda expression path, and this will be equal to lambda taking two inputs O and D. And I want to return a string giving me the name of the origin plus the name of the destination. Enter. And let's invoke that path function. So path, and let's say Cairo as the origin and London as the destination. Enter. And there you go. Origin Cairo, destination London. And let me adjust that so it will be consistent. And let's invoke that one more time, but we'll change the name of the origin to be Tokyo, for instance, and the name of the destination to be Paris. So this was a brief explanation of lambda expressions or anonymous functions in Python. This video is about iterators in Python. Iterator in Python is an object that is used to iterate over iterable objects, like lists, tuples, dicts, and sets. An iterator object is initialized using the iter method, and it uses the next method for the iteration process, so it returns the next value in that iterable object. When you use a for loop, for example, to go through an iterable object, internally, it uses the iter method to get an iterator object, which further uses next method to iterate over. It's good to know though that this method raises a stop iteration exception to signal the end of the iteration. Let's have an example on how iter and next methods work. Let's declare a variable called I_value, which stands for iterable value. And we will give it a value of a string, let's say apples. Let's declare a second variable called I_object, which stands for iterable object. And here we will use the iter method. And we will pass inside our iterable value. Now let's have a while loop. We'll say while true. As I want to show you the stop iteration exception, we will wrap our code inside a try except code block. So we'll say try, and we will iterate by calling the next method. And so we will declare a variable called item, and this will be equal to next method. And inside the next method, we will pass the I object. Then let's go ahead and print that item. And then accept the stop iteration class. And let's go ahead and print a statement telling us that there are no more items to iterate over. And we will break out of that loop. All right, our code is done. Let's go ahead and try it. Let's have a second example on lists. So let's create another value. We'll call it I_value2, and this actually will be equal to a list with numbers from 1 through 5. And we will create a second I object. We will call it IObject2, we'll use the iter method and we will pass inside the I value too. And let's go down here and change the I object to be I object 2. Now, if we'll go ahead and try that, we get the numbers from 1 to 5. Alright, so this was iterators briefly explained in Python. This video is about yield keyword. Let me talk about a very common pattern in programming where you have a function that takes an input or a collection of data, does some processing on it, and returns a new collection of data where each element has been changed fundamentally. Let's take this example shown on the screen where we have a function which called foo takes an input. Then we have an empty list stored in a variable called res. What we do next is we iterate over that input, which might be a collection of data like a list or dictionary or any iterable data type. And then on line 4, we do some processing on that input and then we append it to that empty list. And finally, on line 5 and by the end of that function, we return res. So it's a long process which goes through and taking a list, doing some process and returns a changed one. The problem with this is that it's a long operation. We don't get back any of the values till it's finished. And if this data collection is big, we will have a second copy of it in the memory before we can start doing any work on it really. But what we want to do is we want to take each element and do some processing on it right away and then immediately give it over to the caller of that function. And here the yield keyword comes for a situation like this, where we don't want a temporary collection, which is the res list right here, and where we don't want to iterate many times before we return the value. So in order to use the yield keyword, we will just delete this list right here on line 2. So let me copy this scope block and paste it here. Then let's go ahead and delete that list because we don't need that anymore. We also cannot return the res now because we don't have it. And on line 10, instead of res.append, we will just substitute it by the yield keyword. So yield basically means when you get to this line, line 10, you want to take this value and send it out of the function as the next element in the sequence. And you might think, where do the calling for these values come? Well, if they just iterate over each value, then each value is being handed over immediately while suspending the function for a second. So the process of iterating stops briefly till you ask for the next item. And I know this is an abstract example, so let me give you a practical example so you will get better understanding of the yield keyword. So let's have a function called cube, and cube takes an input of num. Then we will have an empty list. Then we want to iterate over that num, so we'll say for I in num. Then we will do the processing on the input and we will append it to the res list. I multiplied 3 times. And finally, we want to return that res list. Now let's go ahead and create an object. We will call it bar. And here we will invoke our cube function. Then we'll take a list of numbers from 1 to 5. And let's go ahead and print bar python main.py. And there you go, we have a new list with our new cubed numbers. Now let's go ahead and use the yield keyword. And we'll use the same example. Define cube takes num for I in num. And instead of line 16 and 17, we will just use yield and then I multiply 3 times. And let's create our object bar cube 1, 2, 3, 4, and 5, and we will print bar exactly like the previous example. If we run the file one more time, we will have a different outcome. Notice that I'm not getting the previous result. 1, 8, 27, 64, and 125. Instead, I'm getting a generator object at this memory address. And this is simply because generators don't hold the entire result in the memory. Instead, it yields one result at a time, as explained previously. So it's waiting for you to ask for the next result of that cube operation. So actually here, we didn't compute any numbers yet. So what we need to do is we need to use the next method. So we will use the next method inside the print. We'll run the file one more time and then we will get 1. As we said, yield hands over one item at a time, waiting for you to ask for the next item. So if we will copy this line 4 more times and we will execute the file, we will get the numbers from 1 through 125 as expected. Alright, so this was the yield keyword briefly explained in Python. This video is about generators. The prerequisites to understand today's topic is to know yield statement and iterators. You can check out the latest 2 videos in the series. When we talk about generators, there are 2 terms involved. Generator function, which is like a normal function. The only difference is whenever it needs to generate a value, it uses the yield statement instead of return statement. Therefore, whenever a function contains yield, this function becomes a generator function. Okay, let's define a function and we will call it genFun, open close parentheses with no inputs involved, colon, and we will use yield statement or keyword, and we want to yield just the number 10 and 20 and 30. Alright, this is simply our function. Now let's have our driver code to check out the generator function. So we will have a for loop for I in this function genFun. We want to print the I. So it will loop over each element inside the function and it will yield it. Alright, let's open our terminal and let's check it out. Python main.py. We get 10, 20, and 30. So genFun is a generator function because it uses the yield statement instead of the return statement. Now, what about the generator object? Generator functions return a generator object. So generator objects are used either by calling the next method on the generator object or using the generator object in a for loop. Let me give you an example for that. So here, let me put a comment, generator function. Then here we have generator object. So we will have another generator function. We will call it genFun2 without any inputs or any parameters. And we will not yield only numbers, but we will try different data types. So the first yield is 100, which is an integer, yield true, which is a Boolean value, and the third yield, let's say hello world, which is a string. Alright, this is our genFun2. Now, if I will declare a variable, I will call it, for instance, scrap. And scrap will be equal to genFun2 function. If you will hover over scrap, you will find that scrap is a generator. In other words, scrap is a generator object. And let's try to print scrap. Okay, let's open the terminal and let's run the file, and we will find that generator object genFun2 at and this memory location. Okay, so this is not useful as we have seen in the last video. So what we need to do, we need to use the next method. So let's involve the next method in our code. Now if we will run again, we will get 100, which is the first yield. And as we said, the biggest advantage of using generators is that it doesn't use the memory extensively. And if we want to do for true as well, for the second yield, so what we will need to do is just copy that line. And now we have 100 and true. So in order to yield the third value, we will just do the same. And we get 100, true, and hello world. But what if we run it again? We will get an error. If you remember, stop iteration exception So in order to avoid that, let's wrap our code in a try except block. So we will take this, we will indent it inside, except, stop, iteration, and let's print a statement that this is the last item in the code. So let's try that one more time. So we get 100, true, hello world, and our message. This is the last item in the code. Now let me show you a final example that shows generator function creating a generator object. So let's create a function. We will call it add num, which adds 2 numbers, and it takes num as input. For I in num, just a for loop, we want to yield I plus I. Add num is a generator function. Now let's declare a variable called foo, and foo will be equal to add num function, and we want to pass inside our arguments, so we will have a list of 2 numbers, 5 and 2, for instance. Then we want to print foo, and let's check that out. So python run.py, and we will get again a different memory address. Let's use next, and let's run that one more time, and we get 10 because 5 plus 5 equal to 10. Let's copy that line one more time in order to add 2 plus 2. Now we get 10 and 4. But what if we will do it for the 3rd time? Now we can expect a stop iteration error. So let's wrap that again in a try except code block. So here we will say except stop iteration, and we will print no more values to add. All right. And we get 10, 4, and our message, no more values to add. So this is our way to handle any errors or exceptions in our code. So to recap, add num is a generator function. Foo is a generator object. We don't save any values in the memory and wait until we use it. Instead, we yield every value that we really need in order to do some processing on it. Okay, so this was generators briefly explained in Python. This video is about docstrings in Python. Python documentation string or docstrings provide a convenient way of associating documentation. And the documentation could be for modules, functions, methods, classes, and anything else. It's specified in source code that is used like a comment to document a specific segment of code. Unlike conventional source code comments, the docstring should describe what the function does and not how it does it. Now let's see what does a docstring look like. Well, the docstring should begin with a capital letter and end with a period. Also, the first line should be a short description. And if there are more lines in the documentation string, the second line should be blank, visually separating the summary from the rest of the description. How to declare a docstring? Well, the docstrings are declared using triple single quotes or triple double quotes, just below the class, method, or anything that we want to describe. And in my opinion, all functions should have a docstring. Now the question on how to access a docstring can be answered in 2 ways. One way is using the dunder method doc, and the second way we can use the help function. Let me give you an example. Let's define a function. We will call it func1. Doesn't take any input, and it doesn't do anything really. So let's create now a docstring. So I will use triple single quotes, and I will say this function does not do anything. And I will close the triple single quotes. And I can say pass. And pass in Python means skip this line. This doesn't do anything. Now let's access the docstring. So we will take our function 1 and we will access the dunder method called doc. Enter. And now we get access to the docstring. This function does not do anything. So this is the documentation of the function, describing what the function is actually doing. So dunder method doc is the first way to access a docstring, and the second way we said we have help function. So let's take help function and we will pass inside our func1. So we get help on function func1 in module underscore underscore main underscore underscore. Then we get the name of the function, and the next line we have the description. This function doesn't do anything. And we can do the exact same thing with the triple double quotes. I know it sounds weird. Triple double quotes. All right, let's take a look. Let's have another function called func2. And now we have our triple double quotes. Let's describe this function, which basically doesn't do anything. And let's change from pass to return none. Basically, it will do the same thing. And let's take func2 dot the dunder method doc, and we get the same thing. And let's have help function working on func2, and we get the same thing. So it's best practice in Python to write docstrings in functions. And this was docstring briefly explained in Python. This video is about closures in Python. In order to understand closures, you should be familiar with nested functions and first-class functions. You might want to check out a series of videos I've made on functional programming. So if you didn't watch it, go ahead and watch that first. Otherwise, you won't find a problem understanding closures. So let's start by creating a function. We will call it outer func, and it doesn't take any parameters or input. And let's create a variable, and we will assign it to a string, and inside the string we'll say hello from outer func function. Okay. Next, let's create a nested function. We will call it inner func. This inner func function is nested inside the outer func function. And again, it doesn't take any parameters. And what it does, it prints whatever text is declared above. In this case, hello from outer func function. And by the end of the outer func function, we will invoke the inner func. Now let's go ahead and call or invoke the outer func function. And let's check out what will happen. We get a message, hello from outer func function. Okay, so let me walk you through this. When we have invoked the outer func function, this actually has triggered the third line of code, which is a definition of that function. Then declaring a variable called text and assigning it to a string called hello from outer func function, then defining a second function called inner func. And this prints whatever text is declared above. And at the end, we invoke the inner func. So by invoking the inner func, we have printed actually the text which is in the scope of the outer func. And the text variable is also called a free variable, because even though it was not declared inside the inner func function, we still had access to it inside the outer func scope. So text was declared in the outer func function body, but the inner func function, which is a nested function inside the outer function, had access to it and can print it. Alright, so by invoking the outer func function, you actually have invoked the inner func function. Okay, now let's try to return the inner func function instead of invoking it. So the first step to do that is to delete both parentheses and add the word return here. And this will change everything completely. So if you will try to run the file again, it doesn't look like anything happened here. And actually, if you will assign the outer func to a variable, let's say, I don't know, Batman, and you will hover over Batman, you will find that it's indicating the inner func function. Okay, so to show you what I mean, let's print Batman. And you will find that this is a function and the name is inner func. So if you will print Batman dot name, you will find that it's called inner func. So basically Batman is equal to inner func. And this is fascinating because even though we are done with the execution of the outer function, the inner function that we have returned still has access to the text variable. So, to put it simply, a closure is an inner function that remembers and has access to variables in the local scope in which it was created, even if the outer function is invoked already and has finished executing. Okay? So, this is a closure. Batman actually in this case is a closure. And let me show you actually if we will add some parameters here to the outer function. So we will say name, for instance, as an input. And in this case, we don't need that variable, but we will assign text to whatever name will be passed. Okay. And let's actually create, let's say Batman outer func, and as a name we will say Bruce Wayne, and let's add a second variable, let's say Spider-Man, and let's say here Peter Parker as a name. Alright, so we have here Spider-Man and Batman, and both are referring to the inner function. So let me clear the terminal and let's invoke both functions, because Batman now is a closure or is a function that is referring to the inner func or this nested function. And similarly, we'll do the same thing with Spider-Man, and let's run the file. And indeed, we get Bruce Wayne and Peter Parker returned. Okay, so this was closures briefly explained in Python. ASYNCIO or asynchronous I/O is a library to write concurrent code using the async await syntax. ASYNCIO is often perfect fit for I/O bound, not CPU bound, and also a perfect fit for high-level structured network code. And here we'll touch on the concept of coroutines. But before I show you how a coroutine looks like, I would like to show you what a subroutine looks like. You can open your bash or your terminal. Let's go to Python. And a subroutine seems to be a very scary word, but actually it's a simple function. It's also called a procedure, and it's declared by the def keyword. So if I will create a function that prints hello, just hello, and after it prints world on separate line, and let's also print the end. Okay, and if you will call the function, you will get hello world the end all immediately. This is a sequential process. Hello gets executed, then world, then the end with no waiting time. The subroutine or the procedure gets executed all in one go. Now let's type the same code but differently. We will use the concurrency principle, and this means executing a line, then giving some time for the other line to be executed, then receiving a callback telling us that this line is done, for example, then the other one is done, the last one is done, and we finish execution of the whole code. This is the whole idea of the coroutine. So for that, we will use async await. So let's first of all import the ASYNCIO module or ASYNCIO, and we use async keyword def main, and we'll print hello. Okay, now I want to give some time to sleep or to block any other code from being executed. So we say, hey guys, wait until this line print hello is finished executing. And we can block any task from running by using the ASYNCIO module .sleep method, just to give some time to sleep, and let's give it 2 seconds, for example. During these 2 seconds, everything will be frozen until the print hello gets executed. Even if it's done in less than 2 seconds, still everything will be blocked until the 2 seconds are done. Then let's print world. Now let's give it some time to sleep or to block. Let's say for 3 seconds, just for the example to be very clear to you. And at last we'll say the end. All right, and that's it. Now if you will try to call the main function directly, you'll get here a coroutine object main and saved on this memory address on your machine. It doesn't get executed when you just type main. But in order to call the main coroutine, we need to do ASYNCIO or ASYNCIO dot run main. Hello, then 2 seconds block, world 3 seconds block, then the end, and that's it. So this is the main difference between a coroutine and subroutine. And I will probably create a crash course on ASYNCIO in Python because it became very, very important nowadays, something that you will need to know very well if you would like to be a Python developer.